going to get started here, talk about big data with Corticon. I'm going to be starting out by talking a little bit about the different methods that you can access data with Corticon, the ways that, and the scenarios where you would want to be accessing data as part of your rules. And then from there, once we all have the same baseline, Jim's going to be talking about how we've been working with some of our customers that have really moved towards big data processing. Now, as far as the agenda, you'll see some things here that are probably very familiar to you that have been in the product, especially users that have been working with Corticon for a little while now. Moving down here, we have some newer capabilities within the product that have come out in recent versions over the past couple of years. So we wanted to make sure everybody has an understanding of what you're able to do right now. And then moving forward, you might have just seen in Harold's session the REST data access. Try that again. Okay, so the general gist of why we're talking about this is you can access the data in a lot of ways, but in order to get to the point where you are deriving insights from data that you have amassed over just all of the time that you have been collecting data, that's where we're moving from that sort of real-time types of decisioning, so things like am I eligible for a loan, what's my loan rate, to things where we're processing retroactive data that could be in data lakes, and you have very specific ways that you want to be able to query that data to see how you should model your future business. And that's something that we spent a lot of time with for Corticon's roadmap recently and moving forward. Now, these are some more examples of that real-time type of access. You'll hear lots of different flavors of the wording here. Could be just real-time, transactional, streaming. But this is where the speed of Corticon in producing that decision right when that end user is requesting any of those specific use cases that are about real-time types of problems. And more, what Corticon and rules engines, just in concept, are lending themselves to are as a tool for non-developers to be able to gather real analysis from data. So this is where we're getting into things like monthly processing to identify where there could have been optimizations related to adherence rates, adjudicating claims. If you were in the session yesterday, DXC Technologies has developed a solution around episodes of care, so that's something that Jim will talk a bit about a little bit later, but that's where we are identifying a series of events that have happened in the past and realizing that there's a specific order of those events that would have been most optimal for patient outcomes. You can imagine how that's applicable to a lot of different other use cases as well. So getting to that level where we can model rules, not just for that real-time activity, but to where we can use those rules to really slice and dice into data and identify trends and outliers, that's what's more and more relevant today. So Corticon's provided access to data in a number of ways for quite a long time now. So the way that Corticon thinks of data, and I'm just going to zip through this because I know we have some users here, but there's also some people who this is their first exposure to Corticon. The base kind of dictionary with which you're modeling your rules is called the Corticon vocabulary. So what that is I have a few entities, an applicant, joint applicant. Those entities have relationships to one another. So they might be one applicant has a cosigner that is relevant only for that application, and you're going to be defining associations between those entities. Now, this vocabulary and these attributes of each individual entity, those can be specific data objects that you have within your database. They could be something that you're solving for as part of your rules. Or moving forward, they could be accessing data from a REST data source. So using all of that different disparate data, what we're doing is consolidating into one readable dictionary that the business user is able to model the rules with. Now, I spoke through a good amount of that. Again, this is just calling out the entities, attributes, and associations of those entities. And the simplest way to go about solving for data integration is to just pass in all of the data. That's where, as part of the rule execution, you are giving it all of the data it needs. All that you are doing within Corticon is modeling the rules that will define how those pieces of data are going to operate on one another, and then passing that data back. So Corticon isn't accessing additional data as part of that execution. Now, Enterprise Data Connector is kind of the next level as far as integrating data into Corticon. And what that'll do is it'll access data as it needs it from a database through queries using Hibernate in the background. That's very useful for the types of read and write operations that are okay for transactions, where the scale of the amount of data is going to be somewhat limited, because once you get to a certain level of size of data that you're looking to operate on, then having those discrete queries will introduce some limitations as far as performance. And that's where Advanced Data Connector begins to really get into the big data side. So this is where you are really getting your rules closer to the data. So by minimizing that back and forth between Corticon and your database, by maximizing how much or how close you can bring the queries to the rules and define the actual queries that are being done instead of Corticon automatically generating those queries, you can have quite an order of magnitude of performance improvements. And this was introduced in 5.6, which was a couple years ago, and was made even better with 5.7 as far as making it very accessible for a business user to be able to use SQL within, or use very defined queries within their rule execution. So you're not going back to the database for every single transaction that you're calling upon Corticon for. And by introducing ADC, that really opened the doors to a number of other capabilities within Corticon's data access. And that's where we get into batch processing. If we're able to define the specific queries that Corticon is using to go out and grab data at specific points within a rule execution, then it can really be even more impactful if we can define the queries and go out and get them in the thousands and then process them all at once for things like analytics that are more driven around that retroactive analysis. So inherently in the fact that it is retroactive, it's less important to have immediate responses in that transactional format. So being able to look back at past data and be able to perform that analysis in a batch format by going out, grabbing all of that data, operating on it, and then having the result after that, that's really opened the doors for a number of our customers that have had that sort of analysis use case. I'm going to pass it off right here. This is where we're going to get really into the big data side and how Corticon leverages a number of capabilities. So I'm going to pass it over to Jim here.
Okay, all right. Thanks, Seth. So Seth's giving you the overview of some of the data access capabilities that Corticon has, and what I'm going to go into is a little more depth, in particular on the batch side. Of how we actually achieve this with the features that are in Corticon, as well as some custom approaches that customers have done as well. So batch processing, everybody sort of like it's an old paradigm, but it's still very relevant as companies are accumulating more and more data. You got to get value from data. You got to ensure regulatory compliance with policies. So it might seem like a dated notion, but it's still very applicable today. So batch processing with Corticon, are we going the wrong way? Sorry. All right. So with Corticon, we have multiple ways that you can approach batch processing. We do have built-in support within the product. So this was a new feature in 5.7 that gives you the really out-of-the-box batch processing capabilities. But there's other ways you can do it as well. You can do it with a configurable solution. And we understand no one approach is going to be right for everyone. A lot of it's determined based on the deployment architecture and the data type of the data that you're accessing. But with the built-in approach, it's very easy to get going. If you have your data in a database, you can define the queries that are going to be used for retrieving that data for Corticon, and Corticon will basically take control over efficiently retrieving that data, pulling it in large chunks, doing the rule processing on it, writing results back out, and that's all the built-in support. So the characteristics of batch use cases, there's really two use cases that we've seen. The most common by far is when you have discrete data. So this could be individual patient records, it could be individual orders, mortgage applicants, whatever it is, and you've got the set of discrete records that you need to process individually. That's a use case that's very scalable, where the records are independent. If you need to scale that up horizontally, you can do that. We've had at least one case of a lot of correlation that need to be done across interdependent records. So this was, again, a batch processing use case, but it was very different from the discrete because all of the data had to be loaded into one Corticon server. So you're bringing a large volume of data, and obviously that's very memory intensive. That's the biggest constraint there in terms of performance. It's you get to be able to efficiently get the data from the database, but you have to, you have sufficient memory so that you can have it all there to do the real processing. So some of the lessons we've learned. So we've had customers that have done batch processing historically, and we've gotten very much involved with them over the last couple of years to understand the use case, understand what the needs are, how can we best make Corticon address those needs, and that's what led to the built-in capabilities. And there's a lot of things that we've learned along the way. This is just some of them. The whole querying and writing data in large chunks. This is, people have tried to do batch processing with the EDC capability, so the enterprise or the easier data connectivity that's in Corticon. That's based on Hibernate, and it really doesn't work well in a batch processing use case because of just how the object relational model, the data retrieval occurs underneath. It can just result in sort of an exponential explosion of queries accessing the data. So the bigger the chunks you can read and write, the better performance you're going to get. We make sure we always, we're processing data concurrently, keeping the CPU busy at all times. We want all the database connection pool, just good database practice, prepared statements, those can improve performance as well. There's some capabilities in the data direct drivers. You can configure the drivers where they, in some cases, they can be writing data out. So, when you retrieve a large data set, they might write it out to disk so that you can then, just as to sort of get it out of memory, but again, that slows down performance. And again, save the results to the database. We've had, there are options in Corticon that you can set to minimize sort of that post-rule processing, preparing of XML or JSON that would get returned. The more you can reduce that, then the better off you'll be, and you'll get better performance for your batch processing. Now, then the last one is really important: test at scale. We've had this happen a number of times where customers have, they've built a batch processing solution. We had what happened, a customer do it with EDC, and they're like, oh, this worked great. And then they try to go into production and test it at a large volume, and they're like, wait, this just doesn't work. It doesn't scale to meet our needs. And those are bad situations for us to get into because we end up having to come in and help them sort of re-architect their solution. And the EDC was a bad selection for what they chose. Using the advanced data connector is a much better approach. So again, the built-in batch support, this was in 5.7. It allows you to process the data in a relational database. What's really cool about it is that when you're building your decision service, you don't really need to know that it's going to be used to do, your rules are going to be doing batch processing. That's really more just sort of deployment artifact. The way we do this is that it's the way the batch processing works is you pass in a key record. I'll show this in just a bit, and you pass in the key records like customer IDs or patient IDs, and that's used to drive that batch process. But if you wanted to use that in sort of an on-demand mode as well, that's serving some like transactional behind a website, the rules would be the same. You're just passing the patient ID, and the rules would still execute the same. So again, the built-in product, it's highly optimized. It's very horizontally scalable for if you have that sort of discrete record use case. And it gives you control of the queries. And this one's really important. With EDC, it's easy to do because the queries are getting generated for you, but it doesn't work well in batch. With the ADC, which is, and the batch processing, which is based on, you have the control of the queries. And that's really important. When we talk to DBAs, they want really tight control over the queries they're going to be accessing their production databases. All right, so this is quick overview of how it works. You send a batch execute request. So if you're familiar with Corticon, the typical execute request has like a JSON or XML payload. It could be an applicant for a mortgage, let's say. It's all the information you have about them. With the batch execute request, you're going to be sending over a request that has the query that's going to be driving or selecting the data set that you want to do the batch processing on. So, very simple query here. I'm going to select customer ID from customers. Now, you notice I'm picking customer ID. I'm not doing star because the way I'm going to be using this downstream, when I get in the decision service, it's going to be expecting the customer ID, and then it's going to be using ADC to get the information about those specific customers. Multiple ways you can trigger the batch request. You can do it from the web console. It's a REST API call. If you want to integrate it with other systems, you can do that. So the batch controller is a component of the Corticon server, a new component of it, and it basically is managing the whole, the batch transaction, the batch processing that's occurring. Typically with Corticon, you send an execute request. There's no persistence. There's no state that's kept there, and the request just returns to you. This is different in that you're initiating a process that's going to churn through the set of data. So, I told it to select, customer ID from customers. Well, I got to churn through all those customer IDs, so it's going to take a longer time to do that. And that's the purpose of the batch controller. So what it's doing, it's getting the request. It's retrieving chunks of data from the database. You can configure that. I want to retrieve 1,000 customers at a time, or whatever works best for your system. It then passes the sets off to the rules. Now, the rules are, at this point, as I said before, they're just doing their normal rule processing. They don't know that they're writing in batch. They're just getting sets of, in this case, customer IDs. You would use ADC within your rule, within your individual decision service to actually then go retrieve the details for the data. So again, I have control over the query, so I could select star from customers or do something that's more complex here. And then where the customer ID is in sort of, in quotes, the current set of customers that's being used. So when you're defining the queries to use both with batch and with ADC, you have control over not just what the query is, but you can parameterize them so that you can basically use the sort of dynamic parameters, what's happening at runtime, to select the data that you want to operate on. And here, that's what we'd be doing. We'd be selecting customer ID is in the current set of customers that are being processed. And what's really important with this is that, and this is where the big difference between the sort of traditional EDC, if people are familiar with the enterprise data connector, or I call it the easy data connectivity, versus the ADC or advanced data connectivity, is that when you have associated data, so you have customers, have orders, have suppliers, and multiple deep relationships. With EDC, at each layer there, you introduce a whole new set of queries. So I can get all the customers with one, but then for each customer, I need another query to get the orders for that customer. And then for each order, I might need another query to get the items, the details for each item as part of that order. And it just can explode on you. With ADC, what happens is we can retrieve the data in basically a larger chunk. So we can get that set of 1,000 customers. Then we can get all the orders for those 1,000 customers. Then we can just stitch it together in memory, make the associations that are necessary in Corticon. Your rule processing occurs. What the rules are doing. Again, it's the rule modeler. They're not having to think about, oh, this is a decision service that's going to run a batch. They don't need to know. They're just writing rules for the domain that they're working in. And then the updates are written back to the database. And again, you have control of the queries for doing the writes to the database. And this process just repeats. It just cycles back, round and round until it gets through all the data. So just to give you another view, it's like some of the queries that you would have, the parameterized queries for batch processing. You initiate the batch process by with a query that's saying, what's the set of data that you want to operate on, and you're looking to get sort of like the key attribute that you want, customer ID, a patient ID, a case ID, whatever it is that's going to allow you to identify the set of records that you want to work through. You then have queries for reading the data in. You see, I have two queries here. One is selecting star from patient, another is star from treatment. Separate tables, but there's a relationship between them. And what's happening here is, this is an example of where we'll be running two queries to get a set of data and then doing the associations in memory. So again, that's all to reduce the round trips to the database. And then, lastly, committing the changes back with ADC. Again, so you can see how we're doing. There's the parameter substitutions in here. That's what's inside of the curly brackets. That's the dynamic values that are being placed into the queries that are being run. I know some people will say, well, with EDC it's great because I don't have to think about the queries, and that's true. That's the easy data connectivity. That's great and for lots of use cases. But if you're doing a batch processing use case at any scale where you're dealing with millions or billions of records, you want control of those queries, and that's paramount. The biggest factor in Corticon from a performance isn't the rule execution. The rule execution is fast. It's getting the data in and out. So why use ADC and EDC? I talked about this a bit. EDC is great for lots of use cases, and I'm not trying to steer people away from it, because for a lot of use cases using EDC or the easy data connectivity, it's a great fit. If you have data that tends to be flat, not lots of associations, it's a great solution. If you're not doing something at this sort of very high scale, it can also be a very great solution, but you have to make sure you're testing to meet your performance demands. ADC, or the advanced data connectivity, it gives you control of the queries. So there's a lot more tuning that you can do, and we've geared it or built it to be much more high performant. I talked about this, rule modeling, it's unchanged. You don't have to think about it. And this is one of the really nice things. Whether you're using Corticon with database, getting to using EDC to get to a database, or ADC, or even the new REST stuff if you were at Harold's session just earlier, how you're retrieving the data is largely not a concern of the person that's doing the rule modeling. And that's a really big benefit, because you might have, it allows you to, for example, get started on a project and do a proof of concept before you might have access to the data source, so you can start modeling what the rules will do. You might change what the data sources are. The data might be, move into you might have had at one point, it wasn't a database, but now it's only accessible through a REST service. Well, it doesn't mean all of your rules need to change. How you're accessing the data needs to change, but that's just one portion of this. That's the callouts that are inside of your rule flow. The rules themselves, they largely don't care. So Corticon, again, we provide not only built-in batch processing capability, but we provide the ability to create a very customized solution. And if you're familiar with Corticon, the way Corticon is built is the Corticon server is built to be embeddable. In fact, we have a REST, you can deploy as a REST or a SOAP service. Those are just thin layers, a REST layer or SOAP layer that's around the core server. If you have cases where latency is critical, or you're just trying to get Corticon closer to the data, you can put it in process, and we have plenty of customers that do that. And we're going to give you an example of somebody that's built a customer that's built a very customized or highly configured solution for doing batch processing by taking advantage of that. So this is the State of Ohio episodes of care. So this was a big project that we got engaged with them on. It was 2 years ago at this point, might be a bit more. And it was this is a batch processing application, from the start. This is what they needed to do. And basically the use case is that they've got, because of ACA requirements and CMS requirements that are coming down for them. All driving quality of care at the most affordable cost. There's lots of regulations that they have to comply with, and to as part of that compliance, they have to bring in all the data from all the healthcare providers. So you're talking, monthly basis. You've got billions of records here that they need to process. So it's very high volume, but it's very cyclical. It's not like there's just a constant, hum of activity that's going on. It varies a lot. When they do the cycle at the end of the month, well, they got to retrieve all that data. But between cycles, the amount of activity they need is very low. There's still some activity that occurs with Corticon, but it's very small. So again, it's high volume, very periodic in terms of when it occurs. They need to aggregate data from many different sources. You can imagine if you're having to pull data from multiple healthcare providers, the variety of data sources that are there. And again, it needed for it to be very elastic on the cloud. So with them, we help them build a very customized solution. So what happens in their solution is there's some backend systems which aggregate the data. When the data becomes available, they're using a message queue system. So this was originally developed on AWS, but they since moved to Azure. And so basically what they end up doing is with the data aggregator, when it has data that's ready to be processed, it'll do two things. So I'll just sort of walk through this here. The data's going to data aggregation. When it's got data ready, it's going to queue up a message. So again, this entirely cloud-hosted solution. Corticon's up in the cloud as well. They're going to queue a message that there's a record ready, and they're going to write the record out to a shared file system. So when they were on AWS, it was just storing the record out to S3. Corticon's then going to pick up the message from the message queue and say, oh, there's another record to be processed. Great. So it will then go get the data from the file storage. It will do its rule processing. And then when Corticon is done, it'll write the results back out to file storage and queue up the message saying, I'm done. So what's happening here is that Corticon server, it's wrapped inside of a message client. That message client is listening on the queue for another record ready to be processed, another record ready to process. When it gets it, it's just going out, retrieving the data, passing it to the Corticon server to do its real processing, and then it's pushing the results back out where some other backend system or process they have is going to pick up those results. What's great about this solution is that this is really highly scalable. They can take advantage of all of the cloud services that are there for managing the scalability. Our sort of approach to elasticity and scalability and all of that is, we want to make sure that Corticon can fit within the cloud services that you're using, the virtual infrastructure that you have in house, whatever it is. All of those services have great layers to do scaling, scale things up and scale things down. So they can take advantage of the cloud hosting services that can monitor the queue to see that, oh, there's an increase in volume, so I'm going to bring up another instance of Corticon. Or no, volume's gone down, scale it back down. And so they have, again, a highly elastic system here. So on any given day, there might only be a couple of Corticon servers running, but when they do their end of month processing, it just scales up automatically to the dozens that are needed to process the load in the time that's needed. So that's here. And so Corticon is we're built for speed. Corticon is very fast. It's typically transactions take tens of milliseconds. Most of the time in Corticon, it's not in the real processing. In some cases, it can be, but typically, the time is spent getting data in and out. It's passing the XML or JSON to Corticon, preparing the results to go back, or Corticon accessing an external data source. Corticon is stateless, which is great because it makes us very easy to deploy into cloud or container infrastructure. If you want to take Corticon, put it into a Docker container, configure that your script there to not only have Corticon there, but to load your decision services. You have a Docker defined image container that you can then just scale up or scale down as necessary for your needs. And we had a session yesterday about the JavaScript rules, and we've talked a little bit about it elsewhere in this conference. The JavaScript rules is a new capability that'll be coming end of this year. Lots of reasons that we're going there. JavaScript is, it's what powers the cloud. It's, there's our approach for where we want Corticon to run has always been, we want to run where people are doing where they're doing their computing, where they have the needs for the real processing. And JavaScript is everywhere. It's on the back end, it's on the front end, and we want to make sure that we can run the rules there. It's from a sort of a back end standpoint, which I think maybe is maybe in some ways the most exciting part about this is that the idea of being able to have take your rules and deploy them serverless, so that you have just out there as functions on AWS, on Azure, and Convey. It just allows you to take advantage of all of the whole ecosystems there to create workflows for data that are accessing data, transforming data, then doing real processing, and just sort of stitch those into ways and together in unique ways to solve your problems. And so that's what's coming end of year this year. So I think at this point we're off to the question session. So both Seth and I here, so we're happy to answer questions you have about Corticon data processing, whether it's EDC, ADC, batch, REST, or even if you have questions about the JavaScript stuff coming later this year. So. All right. Yep.
Maybe I missed it, but a lot of your examples were batch against kind of relational data.
Yep.
It was already aggregated.
Mm-hmm.
Could you go against non-relational type sources?
You can get to if you want to get to a sort of non-relational data. We have both the relational support and we have the REST support, which is, that was what Harold covered earlier in his session. If you want to get to something like a Hadoop database, then you can do it through a custom service callout, or you can do it through something if you have a REST API that's on top of it for accessing that data. We have one of the areas that we're looking at and is thinking of is, with the JavaScript rules, it's does it make the most sense to support the same sort of like traditional data sources that you have with Corticon today versus more sort of JavaScript, JSON type data sources. And so I expect it will have even closer integration with those types of data sources on the JavaScript side. On the sort of traditional Corticon side, it's going to be through either REST services, sort of traditional SQL interfaces, or if you can do custom callouts as well. Okay. All right.
If I'm processing really big batches
Mm-hmm.
on a periodic basis,
Mm-hmm.
that might mean that my Corticon servers are idle a lot of the time.
Yep.
And really, really busy some of the time.
Yep.
How would that work commercially? That might not make sense from a licensing standpoint to pay for assets that are kind of sitting idle a lot of the time.
Sure.
How Congress have a way of addressing that?
Yeah. So what Corticon has is a burst pricing model, and that was done explicitly to support batch use cases like what was done for state of Ohio. When we introduced the burst pricing model is that traditional Corticon pricing is you pay a certain rate for a certain fee for the number of cores that you're going to license. And as much as we would have loved for state of Ohio to sign get a 100-core license so that they have the full capacity there whenever they need it, it just doesn't make commercial sense for them. It's just not practical. It's really not fair because most of their cycle time is just going to be down. They're just going to have unused capacity. So what we introduced with them was a burst pricing model. So we sort of prorated over the air where we know that, okay, so you're going to run 3 days a year, you'll be running 24 cores, and we kind of figure out a prorated formula there so that we can, we're getting fair value, but also giving them fair value back that's reflective of their usage. Okay. So this is all done on the server. It really has no, Studio is not involved in this. Studio is for producing or your rules and writing your, creating your decision services. Once they're deployed, the batch processing is just a runtime artifact. With our built-in batch processing capability, you have, you're just sending a special execute request to the Corticon server saying, here's the set of records I want to process, and it's just processing through them. The rules, there's no difference from a rule modeler experience. It's just, a runtime aspect or attribute. Okay. All right. If there's no more questions, I think we can break. Okay. Thank you, everybody.